Well, humanoid robotics will advance very quickly. I think we do have some of the Tesla Optimus robots doing simple tasks in the factory. We expect probably later this year. By the end of this year, I think they'll be doing more complex tasks, but still deployed in an industrial environment. And probably sometime next year, I'd say that by the end of next year, I think would be selling humanoid robots to the public. That's when we are confident that it's very high reliability, very high safety, and the range of functionality is also very high. You can basically ask it to do anything you'd like.
Elon Musk just said something on a recent call that should have made bigger headlines than it did. Tesla is building between 10,000 and 30,000 Optimus robots that will do self-play in the real world. Each one learning, testing tasks, failing, recovering, and feeding everything back into a system designed to teach the entire fleet at once. That number is the foundation under one of the boldest promises in robotics. Optimus Gen 3 is supposed to launch this July as the final production-ready version, capable of handling up to 100 expanded tasks every single day. A lot of viewers are still mixing up the Optimus versions, and Musk recently had to clear it up on X. The robots Tesla has been showing publicly are still version 2.5. Musk's exact words were that the company has not shown Optimus 3 yet, calling it sublime, and confirming the most recent demo images were V2 and V2.5. Optimus 3, according to him, is the right version to start producing at roughly 1 million units per year. Version 2.5 itself is not nothing. Tesla refined the exterior with smoother lines, cleaner joint covers, and far fewer exposed cables. The boxy industrial look is gone. The body now has rounded shapes that move it visibly closer to a finished consumer product, instead of an engineering prototype. xAI's Grok voice assistant got integrated, so the robot can answer spoken questions and route you to different parts of a room. The interaction is not lightning fast yet. There are noticeable pauses. Some replies feel hesitant or awkward, but the jump from earlier versions is real. Gen 3 is supposed to push everything significantly further. Musk has hinted at a design optimized specifically for mass production, more natural walking, power coming from Tesla's new AI-5 computer, hands that look and operate far closer to human anatomy, a presence that does not scream prototype. Here is the part that gets lost in the constant flood of viral robot videos. Many Chinese humanoid robots can run fast, perform backflips, box, and dance. Those demos rack up millions of views. The excitement fades quickly when you ask the obvious question: can any of them actually do something useful? A robot that dances does not automatically know how to wash a plate. A robot that sprints across a room can still crush an egg the moment it tries to pick one up. A robot that performs a backflip might have zero idea how to open a refrigerator, identify the right ingredients, place a pan on a burner, regulate cooking temperature, and wipe down the counter when the task is done. That entire chain of actions is exactly what Tesla is targeting. Musk has been clear that Optimus 3 was not built for performance. It was built for jobs people do not want to do not have time to do, or should not have to do. Boring work, repetitive work, physically demanding work, dangerous work. To make that vision real, Tesla has to solve the hardest problem in humanoid robotics: teaching a machine to function inside a world that was built entirely for humans. Optimus has to recognize where the refrigerator is, find the handle, know an egg from a tomato, understand which part of a frying pan is safe to grab, apply exactly the right amount of force, pour the right amount of oil, sense how hot the stove is, know when the food is finished cooking. Every step that feels effortless to us is a complex chain of decisions for the robot. Grip an egg too tight and it cracks. Hold it too loose and it slips. Rotate the wrist at the wrong angle and dinner ends up on the floor. React half a second too late, when someone walks into the kitchen and the robot becomes a safety hazard. This is where the next generation hands matter so much. Optimus 2.5 already pushed walking speed to around 2.6 miles per hour with upgraded leg actuators and a stronger battery pack. Gen 3 is expected to raise the bar significantly with a new pair of hands Tesla believes will set a new standard. A robot that can walk but cannot manipulate objects precisely is still an expensive demonstration unit. That is exactly where many humanoid robots, especially the ones built for athletic performance, fall short. They invested heavily in mobility. The real challenge always lived in the hands. Wiping a table, folding laundry, picking up a glass of water, unscrewing a bottle cap, collecting children's toys, loading dishes, cooking. Every single one of these tasks depends on hands that are strong enough to handle weight, sensitive enough to feel what they are touching, precise enough to perform delicate motions, and durable enough to operate reliably in unpredictable environments. Tesla is reportedly pushing Optimus Gen 3 toward a next-generation hand with 22 degrees of freedom. That number gives the hands far more dexterity than industrial grippers. But degrees of freedom are only one piece of the puzzle. The real difficulty lives inside the actuators, the mechanical muscles powering every joint and finger. Musk has said that building a truly dexterous robotic hand is already incredibly difficult. Manufacturing hundreds of thousands or even millions of those hands at consistent quality is exponentially harder. That is the gap between a prototype and a real product. Tesla is developing custom actuators for different parts of the body instead of buying off-the-shelf components. Hips need heavy torque to support the body and maintain balance. Shoulders need smooth motion. Wrists need flexibility. Fingers need extreme precision. Using a single actuator across the entire robot would create a machine that is heavier, slower, more expensive, and far less efficient. The biggest upgrade in Optimus Gen 3 may not be the hardware. It is AI-5, the onboard computer that lets the robot make decisions instantly without relying on the cloud. If Optimus is carrying food and a child suddenly runs in front of it, or holding a fragile glass that requires precise grip pressure, it cannot afford to wait for an internet response. Those decisions must happen in real time. Humanoid robots face a much harder challenge than self-driving cars. Cars mainly observe and react to traffic. Optimus must understand its surroundings while also controlling its arms, hands, and body as it physically interacts with people and objects. That combination of visual and motor intelligence requires enormous computing power, making AI-5 one of the most important pieces of the entire system. Tesla's long-term advantage may come from what it calls the Optimus Academy. Instead of manually programming every situation, Tesla is creating a learning network. Robots perform real-world jobs, make mistakes, and generate valuable data. Tesla uses that data to improve its software, then sends updates to every robot in the fleet. When one Optimus learns a better way to complete a task, every Optimus can benefit. One robot might move parts in a factory, another could serve food at the Tesla diner, while another cleans homes. Together, they create a growing library of real-world experience that helps the entire fleet improve faster over time. Competition is increasing. Boston Dynamics Atlas focuses on industrial work, while Unitree has attracted attention with lower-cost humanoid robots. Tesla also faces pressure to keep Optimus affordable if it hopes to reach its long-term price target of $20,000 to $30,000. Tesla does not need Gen 3 to master every task immediately. It only needs to perform a few repetitive, high-value jobs reliably. As more robots work and learn, every improvement spreads across the fleet. That shared intelligence, not individual robots, could become Tesla's biggest competitive advantage.